All right, guys, we are still multiplying binomials, just looking at some special cases. So, square of a sum. This plus sign in the middle tells me that it's a sum. That means I'm adding something. This square means that I'm multiplying this same binomial 2 times. So I should expand it. Because that's what a square means. A square means that I'm multiplying something, whatever the square is, twice. So now this just looks like a binomial times a binomial, where I multiply every term in my first binomial to every term in my second binomial. So the first term of my first binomial multiplied by the entire second binomial. And then the second term of my first binomial, which is a positive 5, multiplied by the entire second binomial. I should have did my little arrow trick. Now I have my monomial times my binomial. Remember, x times x means how many x's do I have when I put them together. And x times 5 is 5x. Well, plus positive 5 times x is also positive 5x. And 5 times 5 is a positive 25. Combine my like terms. And we get x squared plus 10x plus 25. What this is called is a perfect square trinomial. Perfect square trinomial. 2x plus 3 squared. That means I'm taking this entire binomial, and I'm multiplying it 2 times so I can expand it. Because remember, an exponent tells me how many times I actually have something. Now, just looks like a binomial times a binomial, where again, I multiply every term in my first binomial to every term in my second binomial. So I take 2x and multiply it to the second binomial. And I take positive 3 and multiply it to the entire second binomial. Now I just multiply. Distributing, of course, 2x times 2x. Remember, multiply the coefficients, add the exponents. How many x's do I have? 2x times 3. Multiply the coefficients. How many x's do I have? Do it again. Positive 3 times 2x. Multiply the coefficients. Add the exponents. And then 3 times 3. Positive 9. Combine my like terms. And I get 4x squared plus 12x plus 9. Another perfect square trinomial. What about the square of a difference? Remember, subtraction tells me it's a difference. So that's why it's a square of a difference, because this square is telling me that I'm multiplying this exact same binomial, x minus 2, 2 times. So x minus 7 times x minus 7, because that's what a square tells me. It tells me how many times I'm actually multiplying something. So, good old repetition in algebra. Multiplying everything in the first binomial to everything in the second binomial. So, multiplying x by the second binomial. And multiplying a -7 by the second binomial. Good old distributive property. Distribute x to x. That means x times x. How many x's do I have? And x times a -7, which is -7x. Then multiplying -7 by x, which is -7x. And multiplying -7 by a -7, which is a +49. Combine my like terms. 7x, a -7x minus 7x. That means -7 minus 7. Combine the coefficients, which is -14. All right, 6x minus 7 squared. Remember, the square tells me how many times I'm actually multiplying that binomial. So 6x minus 7 times 6x minus 7. Like I said, good old repetition. Multiplying each term in the first binomial to each term in the second binomial. So taking 6x and multiplying it to 6x minus 7. And taking -7, because that's the second term in the first binomial, and multiplying it also to 6x minus 7. Notice I got twins. So I need to finish simplifying. So distribute 6x to 6x. Remember, multiply the coefficients. Add the exponents. How many x's do I have? 2. Distribute 6x to a -7, which gives me -42x. Multiply, or distribute, I should say, -7 to 6x on this one, and I get -42x. And distribute -7 to -7, and I get a +49. Combine my like terms, and I get 12x minus 84x plus 49. And these are also perfect square trinomials. All right, what if we have a square of a sum and a difference? That means in the middle, I got plus and minus. So I'm going to show you something that's going to happen, but we're going to take the same approach, multiplying binomials by binomials, taking every term in the first binomial, multiplying it to every term in the second one. So I'm taking x and distributing it to x minus 3. And I'm taking a +3 and distributing it to x minus 3. So distribute x times x. How many x's do I have? And -3 times x, -3x. So distribute 3 times x, +3 times x. And +3 times a -3 gives me a -9. Combine my like terms. All right, negative 3x plus 3x. That's saying that my mama gave me 3x's. And then she took away my 3x's. She took them from me because I did something bad. Do I have any more x's? No, because they're all gone. So I'm just left with x squared minus 9. Because negative 3 and positive 3 are opposites of each other. That means when I combine them, they cancel out. That means I literally don't have any more x's to play with. All right, 6x squared minus 2 times 6x plus 2. Multiply every term in the first binomial to every term in the second binomial. Meaning I'm taking 6x and multiplying it to 6x plus 2. And I'm taking negative 2, because that's the second term, and multiplying it to the second binomial, which is 6x plus 2. So distribute 6x to positive 6x. Remember, multiply the coefficients. 6 times 6 is 36. Add the exponents. 6x times 2. Multiply the numbers. Positive 12. How many x's? 1. Now go to the next set. Negative 2 times 6x gives me a negative 12x. And negative 2 times a positive 2 gives me a negative 4. Combine my like terms. So this is saying I had 12 x's. And my mama took my 12 x's away because I wasn't doing what I was supposed to do. Therefore, since they're opposite, they cancel out. And I'm just left with 36x squared minus 4.